Hello all, good morning. So the previous class we have seen, abstract class, how to create abstract class and how to create abstract methods within the abstract class and concrete methods. So concrete method means there is implementation, we have curly brace open, curly brace close. So abstract method means, abstract keyword we are using, there is no implementation. So the child class should implement the abstract class things. Okay, so we'll see one more example by using this abstract class. So we'll use real-time examples like account account scenario. So we have accounts, right? So bank accounts. So now let me create a class called account. So account. So here I'm not taking any main method. So this is as of now, what is this class? So this is normally concrete class, normal class. So how to make this class is abstract? So by using abstract keyword, we can make it as abstract class. Now this account is abstract class. Okay. Now within the abstract class, we can create one abstract method. So abstract. So this is string. Let me take the data type is string and get account name. Okay. And next, let me define one concrete method. So public int get account balance. Okay. Normally, these are the features we have in banks, right? So this is written say 500, the minimum balance or anything if you. So this is the account class. So next, there are two classes, saving account and current account, which extends account class, right? So create a saving account. Let me create a saving account. Saving account, or else let me, okay, not saving. Let me delete this saving account. Okay, class saving account. Oh, now we can use extends keyword, friends, keyword to extend this account. So whenever you extend, there is a error we have. The type saving account must implement the inherited abstract method account dot get account name, because that is abstract method, right? Unimplemented method. Yes, sir. So you should implement that unimplemented method here. So what, let me give to return here. So return saving account. This is saving account. What type it is? Saving account. Okay, just get account name. Okay, saving account. This is. And there is a override method we have, right? So what is that override method? Get. So there is a account balance. This is our overload method, right? So here, let me return saving accounts means we can put 100. Okay. Sorry, not in double quotes. This is int type, right? Oh, that's okay. It return 100. Okay. Okay. That's all. This is my saving account. So get return method and get account balance method. So you can see overrides equal implements. Next, now let me create one more class which is current account class. Okay, current account class. So this is also extends account. So whenever you extends, there is an implemented method you need to implement it here. Now this is current account. Current account. That's it. Next, there is a override method, right? We have. So here, date. So account balance is override method we have. So here, so just this is current account, right? Current account means this is not saving account. So let me give 5,000 here for say minimum balance kind of thing. Okay. Okay. 5,000. Okay. So that's all. Then, so we have a test class, right? Now we have a test class. So or else you can create one more class, test account, test account with main method. I am taking main method to execute those child classes. Okay. So now, okay, here, here. So this is my test account class with main method. Saving account. Okay. See, abstract classes are not accept objects, right? We cannot create objects to act abstract classes. If you want to create a account A equals to new account. New account. There is a error. See, what is that error? So can't initiate the type of account. Okay. What it is showing? So because it is abstract class. So only concrete class object you can create. So that is saving account. So say equals to new saving account. This is saving account, right? Let me spell mistake I have. Okay. Okay, perfect. We created saving account. And within the saving account, we have two methods, right? Now, let me this out. Okay. So SA dot get account name first. Okay. Next, we saw SA dot get account balance. Right. So this is one check. Next one, current account. Current account CA equals to new current account. Okay. So this how. So CA dot get account name. I get this out. CA dot get account balance. Okay, perfect. Okay. Okay. Now we created successfully these child objects through we are accessing the methods. So let me run this. Okay. So now this saving account, get account name is returning saving account and it return 100 and current account return this current account and 5,000 it return. Right? So for a abstract class, you need to implement the class, current account, and override method. If method is already override, implemented method in parent class, and you should implement that. Okay. So this is your abstract class, right? So we have abstract class. We can add concrete methods, abstract method. So abstract methods, there is no implementation. Concrete methods, there is implementation. And if you go to there, so this is a saving account is the extends account, right? Now with this saving account is child class. This account is parent class. Now whatever the parent class have any abstract method, there is no implemented. You should implement here within the child class. Okay. This current also same. We are doing. So, and also abstract class, we cannot create objects. Okay. So this is override method. This is implement method. So this is how we can create abstract class. So you can take abstract methods as well as concrete method. Okay. That's it. So, but if it is an abstract class, you cannot create instead. Okay. See, so in our OOPS concept, what are the OOPS concept? We have class, object, inheritance, abstraction, encapsulation, polymorphism. So all are covered. How? How means we create a class. We created a class. We create a object. Next, we create a class. We create a object. And inheritance. So parent, child extends parent. So this child extends parent, right? So parent extends child. Next, abstraction. So this is the abstract method. Where is the account? You see here, account. This is the abstract method. So there is no implementation. Okay. I want to implement. So I want to implementation. Then only I will provide my child classes. So I provide abstraction. So what is required I am showing you, and what is not required I am not showing you. This is required abstract method signature. You want to display to this, right? See, if suppose clients wants to me show me that code, so what are the things are available class? So I'm not sharing my saving account. Okay, I'm not sharing my saving account. Here we are implemented, right? The code. So instead of sharing my account, if I share my saving account, client also know the logic how I am implemented. Instead of that, I am sharing the account. Okay. So here also the balance is abstract method and I share this. So you know that in account class, get account name and get account balance are the methods. So what I do? Okay. Okay. Next, polymorphism means so polymorphism we have seen, right? So this is same method. So this is same method, get account balance. So this account balance we are going to overwrite here. Yes or no? So this is also same method. Exhibit 2. So there are five. See, here account is written 500. The same method here it written 100. So this is dynamic polymorphism. Override is dynamic polymorphism. In overload case, so that is in possible within the same class, and there might be a signature difference. Means parameters. It can take, so without parameter, with three parameters, with two parameters. So that is also overload. That is static polymorphism. Okay. Same method exhibit different forms. That is static polymorphism. So polymorphism, two types: override overload. Okay. Next, encapsulation. So where we covered encapsulation. So there is a student class, right? Not student, employee. So employee class, right? So I have private properties. So if I want to get these properties, I can call this method. Okay. I only public methods. I'm using public members. So this is called encapsulation. So binding your private variables with a public members. So if I want to get employee ID, I just call get employee ID. Okay. This get employee ID. If I want to get employee ID, I can call this get employee ID. I can get the value. Employee ID written. But he can't update or modify the variable because this is private. So this is encapsulation. So all OOPS concepts is covered. Okay. Class, object, inheritance, abstraction, encapsulation, elements. All six concepts are clear, covered. Okay. So I hope you are all understand this. So there is a one more concept in Java baby. So what is this? So we have one more concept called very important. So that is interface concept. So what is interface? So interface is abstract. It contains all abstract methods. Okay. See, so it is also similar to abstract class, but the difference is in interface all the methods are abstract. There is no concrete methods. So in interface, so is abstract. All interface methods are abstract methods. Okay, all interface methods are abstract methods. Okay, and if you want to implement those interface abstract methods, see here. So or else let me open. So class to class, we use keyword called extends, right? Class to class. But now class to interface, we can use implements, implements keyword. So it implements the unimplement method of your interface. So it implements the unimplement method interface. Okay. So because the interface are having only abstract methods, right? So abstract methods means there is no implementation. So we should implemented those abstract methods in child class. So we'll see. So let me take one example. Let me create one interface. So here there is an interface. You can go here also. You can take here as well. So interface. Let me take interface. So count animal child all example. Okay. So tree as a interface. Tree. So Chetu. So my interface name is tree. And so tell me what are the properties are there in tree. So like we have public. See, I told all interface methods are abstract methods, right? Abstract string get tree name. So that is one abstract method. And public public abstract int get ph. Okay, I have two abstract methods. I want to implement this abstract method. If you want to implement anything in the abstract or interface, only class. Okay, only class is possible. So let me create class. So let me create mango tree. So mango tree. So this is mango tree class. So class to interface, I said implements. So implements tree. Okay. Now whenever you implement tree, there is a error. So the type mango tree must implement the method abstract method tree dot get tree. So we have two methods are there. So you can just click add and implement it. So now let me remove this on it. So here the tree name mango tree, and next this should be, so some age you can define 15 years. Okay, 15 years. So if you see here, implements. Okay. All right. Oh, so 15 years. So mango tree implements tree. There is two implemented unimplemented methods is there in tree. So we are implemented this. So let me create test tree class with main method. Test tree class with the main method. So the main method is the starting point of execution. So with main method here, like abstract class interface also you cannot create object. Okay, tree t equals to new tree. If you see here, that is not possible. Interface also we cannot create objects. Okay, so cannot initialize of error tree. So why error? So if any class, abstract class or interface contains abstract methods or abstract methods like interface, we cannot create objects for those. So for abstract class, we cannot create object. This is also not possible for interface. So how to create mango tree empty equals to new mango. This is how we can create sysout. So empty dot get tree name and sysout empty dot get tree age. So ends with semicolon. Now run as, see, mango tree 15. So now you can see the implementation, right? Get a tree age. So it is going to mango tree, that is written. You can see the implementation. So you have to provide abstraction. How I'm not providing abstraction here. So this is one way of creation of object. So how to create abstraction here? So what is second way? So tree partial mango tree object. Tree t equals to new mango tree. This way you can create it. Okay. So now say sort dot t dot get name and say sort t dot get t dot get h. Okay. See, mango tree 50, mango tree 50. Okay. So this is partial. This way of creation, object creation is partial. So partial partial mango tree object, and this is what type it is? Pure mango tree object. Okay. Now, if you see here, now you can see here, tree t equals to new mango tree. Get tree name. It returns abstract method. It is not showing implementation. Get a tree h. It also going unimplemented method. If you run this, here, but the runtime it will decide which method is going to invoke. So compile time it is not showing. So dynamically it is decided. So always create object against the interface instead of direct object. So if you create this, if you create direct object, the child class object, the implementation you can see here easily. So you can see easily the implementation of the method. But if you provide abstraction to this, you cannot see the implementation directly. So here you are maintaining abstraction. So this concept is called way of creation tree with respective interface is called coding to interface. Okay, what it calls? Coding to interface. Coding to interfaces. Okay, so always recommended to create like this for abstract class also. Okay, account also you can create it. Before we have seen example, right? Account set. Like that you can provide abstraction. This is abstraction. So clear. So one more important point is, so this is my interface, right? So see, where is my interface? This is interface, right? So I don't want, so there is two unimplemented methods. So this mango tree implements interface, right? So if I say implements the tree interface means it should, whether you like or does like. Okay, you have to must and should implement all unimplemented methods. Suppose if I have one more method. Suppose if I have one more method. What method it is? So let me create one more method. That is get next. So let me set string get tree color. So now if you save here, there is error. So because there is an unimplemented method, you need to implement here. So whether you like or dislike. Okay. So let's say green. Green. Okay. Okay. If it is an interface, it contains all abstract methods. Okay. Only abstract method. The class which implement interface must and should implement all unimplemented methods. There is a scenario. So I don't want to implement all these three methods. I have a scenario. I don't want to implement all three methods. I am only interested for one method. So in that case, what you have to do? So whatever class you created, so whatever class you created, you just make this class as an abstract class. Okay, you just make this class as an abstract class. Abstract class. If it is abstract class, you no need to implement these two methods. Okay, if it is abstract class, you no need to implement. Okay, so see, you don't want to implement these two. Okay, now it extends subclass again. There is one more class becomes to it contains the abstract class. You cannot implement remain unimplemented. Okay, this is how we can do it. So if you create an abstract class, so abstract class also we cannot create objects, right? Then again you can create one more class which is extends this class. Then you can create that class to access this. I hope you are all understand this scenario. Okay, let me show you.